Hi everyone, welcome back to PW International Boards. Friends, in this video, we are going to complete another topic for Cambridge IGCSE Physics. And these topics are mass, weight and density. This is part of your first section, that is motion, forces and energy. Now, these topics are very important because in almost every paper that you are going to see from past year, you are going to find at least one question from each topic, right? So in today's class, the topics that we are going to cover are mass and weight. So definitely we are going to talk about the difference of mass and weight. We are going to first define them. Then for every physical quantity, we are going to talk about how to measure these physical quantities. So we are going to talk about how to measure mass, what device we are going to use, how to measure weight. Then after that, although from gravitational field and gravitational field strength, we don't see a lot of questions coming from these topics, but still we are going to cover this. Then the next topic is again very important. In almost every paper you are going to see questions from density, and then similarly we are going to talk about the how to measure density for an irregularly shaped solids. So these are going to be the topics that we are going to cover in today's class. Now let's start our class with mass. So when we say that a mass of a body is, let's say, 5 kilograms, so what do we really mean by it? How we are going to define mass? So the definition of mass can be given as it is the amount of matter, it is the amount of matter contained in the body. So if we are saying that it is basically the amount of matter that is contained in the body, this means that mass is going to remain constant. So now this is actually one of the most important concept, and I'm just exposing this concept to all of you at the very start, that mass will remain constant because this is basically it depends upon it is basically the amount of matter contained in the body. Now if you're going to take this body to some another planet, to some another celestial body, mass is not going to change, right? So it is the amount of matter contained in the body. Next thing, the in the SI system, its unit is actually, its unit is kilogram, right? And for CGS system it is going to be gram. It does not have a direction, so that means it's a scalar quantity. And from this statement that we have written that it is just an amount of matter, we are going to also say that it means that mass is constant for a given body, unless you're not like changing the shape or size of the body, or you're not cutting it, the mass will remain same. Mass is constant for a given body. So like any other physical quantity, it is very important to define it. Then we are going to talk about its SI unit. Probably we are going to also talk about its CGS unit. For in this case, that's going to be gram. And then we are going to talk about whether it is a scalar quantity or a vector quantity. So for mass, it's a scalar quantity. So if let's say somebody says to you that we have got a body, we have got a ground, and on this ground we have got a body which is kept, and its mass is 5 kilogram. Its mass is given as 5 kilogram. So just by looking at the unit, we can say that we are talking about mass. So units are going to be your friends for identifying whether we are talking about mass or whether we are talking about weight. Please remember the SI unit for mass is going to be kilograms, or it could be grams, it could be milligrams, it could be micrograms. Anything related with grams or kilograms, it is going to be just mass. Moving on, so these are some of the notes that we have just covered. Mass is a fundamental quantity, so this is very important, that it is a fundamental quantity in physics that represents the most basic property of matter. It is defined as the measure of the amount of matter contained within the body, and the SI unit is kilogram. Some of the conversions I would like to write for all of you, that 1 kilogram obviously it means 10 to the power 3 grams. Other than that, please remember that 1 milligram is actually 10 to the power minus 3 grams, and this will be actually equals to 10 to the power minus 5, sorry, minus 6 kilograms. All right, moving on. Now we are going to talk about how we are going to measure the mass of any body, right? So now this is very, very important. The first thing that we are going to use to measure mass can be a beam balance, it could be a lever balance, or it could be a digital top pan balance, right? So now this is very important. You must have seen it, that usually we in the older times, people used to actually measure weight using something like this. This is called as a lever balance or a beam balance. So we have got, just a second. So let's say we have got let's suppose we have got a lever, we have got a beam balance, something like this, and on this there is a known mass kept on one of its end, something like this, and this is the known mass, and let's suppose this mass is actually of 10 kg. Now if we have to calculate the mass of an unknown solid, let's suppose that we have got an unknown solid kept over here, and we have to calculate its mass, and it balances accurately. That means that this body has also got mass of 10 kg. So that's how you are going to actually find out the mass using a beam balance or a lever balance. Also, in modern times you can find the mass by using a digital top balance. Now, when we are going to talk about, obviously the next topic is going to be about weight. Now the confusion is going to start, because when we are going to talk about a weighing machine, the confusion will actually start. So now it's really important to actually distinguish between mass and weight, along with defining just weight, right? So first let's define what do we really mean by weight. And for defining weight, I'm going to actually draw a diagram. Let's say that we have got a ground like this, and on this we have got a body whose mass is m kg. So now you know that what do you mean by m kg. So its mass is actually m, and we know that earth is going to pull this body. I'm going to just move these things a little up. Earth is going to pull this body because of gravitational force, and that gravitational force is going to be equals to mg. So this is going to be equals to mg, and this value is actually called as weight. This value is actually called as weight, right? So weight is nothing but it is basically the force with which the earth pulls the body down. So weight of a body is the force, the force with which earth pulls a body down. So it basically means that we are talking about two types of thing. So we are talking about that basically force is a weight. So it means that it is going to be a vector quantity. That's for sure, because it's basically force, right? And the SI unit is going to be newtons, denoted by capital N. These are some of the things that we can easily say just by looking at the definition. The next important thing is that we have said that the force with which earth pulls the body down. So it means that if you are going to talk about some other celestial body, if you are going to talk about moon, then on moon we are going to say the weight of a body on moon is the force with which moon pulls a body down. It means that weight is actually not constant. So weight is going to change when you are going to actually if you are going to talk about some other celestial body, it might also change because of change in acceleration due to gravity on the same planet as well, right? So we are going to talk about all of those things, but first and foremost we can say that the because of this concept, because of this point, we are going to say that it is weight is not constant. Weight is not constant, as it depends upon more than one things, right? So we are going to talk about all of those things as well. So for force, we have talked about that it is the force with which the earth pulls the body down. It is a vector quantity. That means that it has got direction and it has got magnitude. Magnitude is equals to mg. Direction is actually towards the center of the earth. Moving on, reading the same things over here again. Weight is the measure of the force of gravity exerted on a body. So it's another way to put the same thing. Since weight is a force, its SI unit is same as that of force, which is Newton. Weight depends on the mass and acceleration due to gravity. Obviously, we can see over here that weight actually depends on mass and gravity. Moving on, the weight of an object can be measured by hanging on a spring balance marked in newtons. So if, let's say, if you're talking about weight, which is actually a force, so what you can actually do is you can actually use a spring balance. You can actually use a spring balance to find the weight of the body. And how we are going to actually use a spring balance, we are going to talk about it. So spring balance looks something like this. Obviously, on a spring, if you're going to apply a force, and right now the force is being applied in the downward direction, and this force is actually equals to mg. This force is actually equals to mg, and because of this force there's going to be an extension in the spring, and that force can be written as mg. Further, we can write for force, we can write kx equals to mg, and x can be written as mg by k. So this is the value of, this is actually your extension. This is how you're going to actually find out the reading in a spring balance, right? So the amount of stretch in the spring corresponds directly to the force of gravity acting on the object, with greater pull resulting in more significant stretching of the spring, right? With this, let's move on. Now we have got difference between mass and weight. So the first difference is mass can never be zero, right? Weight can be zero, as in space, no gravity acts upon the object, its weight becomes zero. So the first difference is quite easy to understand and very important also. So it's very important to know that weight can be zero as it depends upon the gravity. So if let's say gravity acceleration due to gravity is zero, then weight will become zero. Further, we are going to say that mass is actually a scalar quantity, whereas weight is a vector quantity. All right, it has magnitude and directed towards the center of the earth. So we are also talking about the direction of the acceleration due to gravity over here. Mass is commonly measured in kilograms or grams, whereas weight is commonly measured in newtons. And what do we mean by newton? So when we are going to talk about newton, newton is basically kg meter per second square. So this is what unit basically means. That is mass times acceleration. Mass doesn't change according to the location, so that means it is constant. Weight varies according to location. The mass may be measured using an ordinary balance. Weight is measured using a spring balance. So here comes another question. So if this is all about mass and weight, so what does really weighing machine measures? This is an interesting question, because And many a times in the past papers they have actually talked about it, that let's suppose they have told you that they have got a table over here and they have said that we have got two readings, and those two readings are actually something around 60 kg and around something around 580 Newton, or let me be precise, if I'll just multiply 60 by 9.8, which is actually acceleration due to gravity on Earth, that's going to be 588 Newton. So I've got like these two readings, right? So now the question is basically asking that out of these two, which one is weight and which one is mass, right? Now my second question is, obviously you're going to, now you can answer it very easily. You're going to say that because we are going to just look at the units, so kilogram is unit for mass, so this is going to be mass, whereas Newton is the SI unit for weight, so this is going to be weight. Sorry. So it basically means that weighing machine, does it tells us, does it measure mass? Because when you're going to step on a weighing machine and let's suppose your mass is 60 kg, the weighing machine is going to tell you that it is 60 kg, right? So what does weighing machine measures? So here's the confusion, and let me explain it. Let me clearly explain this problem to all of you. Weighing machine, actually what the weighing machine do is I'm going to actually draw a diagram over here. Hopefully I've got enough space. So let's suppose that I've got a weighing machine kept something like this. This is a normal your bathroom weighing scale, right? And we have got a body which is kept on it something like this. You've got a body kept on it something like this. So we know that there's a force of gravity which will pull this body down, and that value will be actually equals to mg. The weighing machine does not measures mg, it actually measures the normal reaction, right? So it basically measures the normal reaction to that will be applied by the ground on the body. So it will measure the mg, and then it will actually, well, for a flat surface normal reaction will be equals to mg. Then what it will do is actually it is calibrated in such a way that it will give you reading by something like this, that mg divided by the acceleration due to gravity on earth, that is 9.8, and this is going to be the mass of your body. So the thing is that weighing machine really measures the apparent weight. Weighing machine measures the apparent weight, but it gives the reading in the form of your mass. So there's a difference, right? This is because there's a calibration done in the weighing machine to give your answer in the in like in kg, in kilograms, and that is your mass, not your weight. So with this, let's move to the next topic, that is gravitational field intensity. Before gravitational field intensity, let's also talk about gravitational field. So gravitational field is basically an area around a mass about which another mass can be attracted towards it, or another mass can actually feel the attractive force, or the attractive force can be applied on that another mass. Meaning, let's say that we have got a body over here, we have got a body kept at this particular point and its mass is m. So an area around this body, about which, if you are going to bring another mass, let's say we bring another mass of 1 kilogram, so this capital M will actually apply a gravitational force on this body, and also the 1 kg will also apply the gravitational force on the capital M mass, right? So this region is known as gravitational field. Now with that, if there is a gravitational field, we can also calculate the gravitational field strength of it, that means the intensity of it. So this is nothing but this is strength, and we are going to define it something like this, that gravitational field intensity is the we are going to say, like for example, as we are going to write that we are going to use the case for earth, we are going to say that let's suppose that we have got a block kept over here, whose mass is actually m, So the force with which the earth is going to pull this body down is going to be mg, right? So force is going to be equals to mg. So the force per unit mass is actually known as the gravitational field strength. So we are going to write something like it is the force, or we will write it as gravitational force. It is the gravitational force per unit mass. That means G will be defined as the gravitational field strength, which is actually also equals to your acceleration due to gravity, with unit of meter per second square. With this, let's move to the next one. Gravitational field is defined as the gravitational force experienced by a unit mass at a particular point. It is a vector quantity. Sure, it is indicating both the magnitude and direction of the force a mass would experience at that location. Moving on to the next topic and the next part of today's class, that is density. When we are going to talk about density, that density is actually a quite easy concept. Density is the ratio of mass and volume. So we can write density to be the ratio of mass and volume. Now, what does basically density tells us? So density tells us that how compact how compact mass has been fitted, or mass has been contained in a body. So if let's suppose that we have got 10 kg of block, and 10 kg of block is contained in a, let's say, inside a 10-meter cube volume, and the same 10 kg is being contained in a 100-meter cube volume. So we can say that the larger the volume, the less dense the body is going to be, keeping mass constant. So we are going to say that over here, density, mass is measured in kilograms, volume is measured in meter cube. Obviously you can use some other units as well, but if you're going to talk about the SI units, so the SI units for density is actually going to be kilogram per meter cube. Plus mass is a scalar quantity, so is volume a scalar quantity. So it means that density is also going to be a scalar quantity. There can be more units for density, and those units can be, first of all, the SI unit is kilogram per meter cube. But if you're going to talk about, so this unit is actually the SI unit. But if you're going to talk about some other units, it could be something like gram per centimeter cube. So this is actually the CGS unit, right? Or it could be like in the volume can be measured in liters, it could be measured in milliliters, all of those things. Then next thing comes, density represents the concentration of mass within a specific volume of material, indicating how tightly packed the matter is in that area. Defined as mass per unit volume, density is a fundamental property of material. So we have already covered all of these points. Moving on. Now here we have got some densities of certain materials. Like for example, if you are going to talk about certain some metals or some solids, aluminium, copper, and these are densities in gram per centimeter cube. So we have to be very certain about it. Iron, gold. Out of all of these things, you must remember the density of pure water. The density of pure water is actually 1 gram per centimeter cube. Or if you want to convert it, like for example as density, let's talk about the density of water. Usually we also be sorry, sometimes we denote density with the symbol of rho. So if rho is actually 1 gram per centimeter cube, and if you want to convert it into kilogram per meter cube, so what we are going to do is we are going to write, instead of gram, we are going to write 10 to the power minus 3, and this will be written as in kilograms, whereas 1 centimeter is written as 10 to the power minus 2 centimeters. So this will be written as 10 to the power minus 6 meter cube, because we have got 3 centimeters. Converting all of them, it would be 10 to the power minus 6. So this will actually become 10 to the power 3 kilogram per meter cube. So what does this means? This means that let's suppose that if you have got a cube, something like this, and this cube is of unit length, the edge length is of 1 meter. Let's suppose it has got edge length of 1 meter, 1 meter cross 1 meter, and we are going to actually, let's suppose that we are going to fill this cube with water. Let's suppose we are going to fill this cube with water. So the mass of this water is going to be of 1000 kgs. So that makes the density as 100 kg per meter cube, right? So we must remember, for pure water, for gases, the density is going to be very, very less. You can just compare it with water. For air, it is just 1.3 kilogram in 1 meter cube. For hydrogen, it is 0.09 kilogram per meter cube. So gases are quite less dense, right? Whereas aluminium is actually 2.7. That this will basically means that it is actually 2700 kilograms per meter cube, or let's say copper is 8900 kilograms per meter cube. So this makes solid to be the most dense, then comes liquid, and then comes gases, right? With this, let's move to the next part. How is density calculated? So first of all, if we want to calculate density, obviously it's the ratio of mass and volume, but how you are going to actually calculate it, right? So that's the important thing that we are going to actually talk about it. Now we know that density can be actually written as mass by volume. So if we really want to find out the density of any object, of any body, then it means that we first have to actually find out the mass of that object, and we know that mass will be found out using a pan balance or a lever balance, right? So basically we are going to just write that we are going to use a balance for finding out mass, and for volume we have studied this from the last class, from the previous class, that volume is measured using a measuring cylinder, right? In today's class even we are going to talk about measuring cylinder. So using these two things, we can actually find mass and volume, and then we can find out the density of any object. So if the object is actually object can be of two types. If it has got a definite shape, and it happens to be a polygon, like for example, as so the first case could be it has got a definite shape, for example as a cube or a cuboid, or let's say a sphere. So for those one, we can actually directly write the volume as using the formula for that particular shape, right? And if we have got an irregular shape solid, then for that we'll surely will have to use measuring cylinder. Although measuring cylinder will work for any sort of solid, whether it has got a definite shape or it has got an irregular shape. But if it has got a definite shape, then why would you actually need a measuring cylinder? If you already know, for example, if you have got a cube, all you need is actually a ruler scale, right? Using a ruler, you can find out the edge length. Using the edge length, you can find out the volume by using the formula, and then you can find out the density of the object. Moving on, unit of density, we have already covered it. Unit of density is going to be, the SI unit is going to be kilogram per meter cube. So this is going to be the SI unit. You are going to mostly use this unit only, and the CGS unit is going to be is going to be gram per centimeter cube. So this is going to be the CGS unit. So this is going to be about unit. Moving on. Now this is how you are going to actually measure the volume of an irregular solid. So let's suppose that before dropping down this solid into this flask, the reading was actually this. So this was the first reading. Let's say this is actually R1. And after dropping the solid, the reading becomes R2. So the volume will be, the volume is going to be reading R2 minus reading R1. This is going to be the volume of the solid. So it's quite easy. Moving on. So this is the procedure through which we can actually find out the volume of any solid. So the first part was to drop down that solid into that measuring cylinder. Second step is measure a certain quantity of liquid in the measuring cylinder. Let it be V1. So V1 is actually the reading one that we have written it. So this is the reading V1, and then after dropping it, the reading is V2. So the volume of the object is going to be V2 minus V1. All right. Moving on to the next part. If you have got a liquid, whose density you want to actually find, you want to actually find it out. So what you can actually do is, let's suppose that you have got a container, and you have got, first you have got a flask into which you are going to actually pour the liquid. You're going to actually pour the liquid into the flask, and then what we are going to actually do is we are going to actually measure the mass of this flask. We are going to actually measure the mass of flask plus liquid. Then we are going to actually measure the mass of the flask alone. Measure the mass of the flask without water. And then let's say this mass was M2, this mass was M1. So the mass of the liquid is going to be just M2 minus M1, right? So this is what I have written. Then after this, we are going to actually find out the volume of liquid. Either it could be a volumetric flask, so there must be reading on it, or you can use a measuring cylinder for this. So volume of the liquid can be easily found out using a measuring cylinder, and that's how you can actually get to know what volume of liquid is. Now you're going to use the same technique to actually find the volume of gas as well. So you have got notes over here, so you can always use these notes. For air, or like for any gas, things are actually a little bit more complex, but in simple terms, if you are not really going into the pressure and the volume and the temperature, so we are going to again say the same things. We are going to actually measure the mass of the gas, measure the mass of a flask in which we have poured the gas, and then using a vacuum pump, we are going to let the gas out, and we are going to then measure the mass of the flask alone. That's how we can actually measure the mass of the gas, right? And then again we can use a liquid to actually find the volume of that flask. Using that, we can again find the density using the mass by volume, but this is actually not that accurate. The most accurate way is going to be actually using the equations like of ideal gas. So we are going to actually say something like, let's suppose that the equation of ideal gas is PV equals to nRT. Now we are doing all of this experiment under the 1 atmospheric pressure. So pressure is actually equals to 1 atm. So volume is actually will be actually equals to the number of moles that you have taken times gas constants times the temperature, which could be the room temperature. So you can also find it like this, right? Moving on. So this is the notes for finding the density of air. Now let's talk about floating and sinking concepts that are related with the densities. Now, according to this concept, let's suppose that we have got a container, something like this. And in this container, we have got different liquids with different densities. And those liquids are something like this. So we have got liquid A, B, and C. And now with this diagram, I want you to know, I want to know the order in which or the order of density they have got, right? So the liquid which is actually at the bottom most is actually it has got the maximum density. So it has got the maximum density. Then the C part, which is actually at the top, it has got the least density. So it means that density of A is greatest, then comes B, and then comes C. So this is a concept, and on this concept you are going to actually see some of the questions from the past year as well. So if a liquid has got greater density, then it will go down, right? It will be heavier, and if it has got a lesser density, then it will actually float. So this is related with the floating and sinking concept. Now let's solve some of the questions, which is actually the main thing about all of the this getting all the theory is not that much important, but solving past year problems is actually the main thing. So the first question says, on Mars, the acceleration of free fall is 3.7 meter per second square. So this is actually that thing, that small g. So small g on Mars is actually 3.7 meter per second square. What is the weight of 2 kg mass on Mars? So the mass of 2 kg will be 2 kg, but if you are going to talk about the weight on Mars, that will be the mass of the body times acceleration due to gravity on Mars. So this is going to be 2 kg times 3.7, right? So that's basically and I think we have kept everything in SI unit. There's nothing. So this is going to be actually 7.4 Newton. All right. Moving on. Let's move to the next part. Hopefully we have taken everything in the SI unit. 3.7 times 7.4 Newton. Moving to the next question. Which row describes how the volume and mass of liquid mercury change? This is actually change as it is heated. All right. So this thing, first of all, this thing is actually change as it is heated. So first, now the thing is that mass remains constant even if it is heated or if the temperature has gone down. So this thing is actually constant. So mass will remain constant. And now if liquid mercury is heated, it is going to expand, right? So on heating, things expand. So that means volume is going to increase. So volume increases and mass remains constant. That means option D is absolutely correct. Moving on. A student has a measuring cylinder containing water and also has a balance. Which of these could she use to find the volume of a small metal sphere? She has no other apparatus. So if actually she just want to actually find out the the volume of the small metal. So if she just want to find the volume, then for finding out the volume, all she need is actually just the measuring cylinder. She doesn't need a balance, right? So the measuring cylinder containing water only is going to be the correct answer. Fourth one, a table gives data about 4 liquids W, X, Y, and Z. None of the liquids mixes with any of the other liquids. All the liquids are put into the same container and settled to form the 4 separate layers. Which statement is correct? So so again, so this is what I was talking about. The layer, the liquid which is going to form the top layer is going to be the the liquid which has got the least density. Now, out of all of these things, first let's find out what the density we have got over here. So this is 10 gram, this is 10 centimeter cube. So what I'm going to do is actually I'm going to draw another table over here, and I'm going to actually write density on this one. So we are talking about density, and this one is going to be around 1, and this one is going to be around 20 by 15. So to be precise, 20 by 15 is going to be 1.33. This is going to be 1.33. Then 30 by 50 is going to be just 3 by 5, which is going to be around 0.6. So 30 by 50 is going to be 0.6, and this is going to be 0.2. 40 divided by 50, sorry, 0.8. So this is going to be 0.8. So we can see that this one is the maximum, this one is the maximum, and this one is the minimum. Now let's figure it out. W forms the layer below X. According to this, they are trying to say that the density of W is actually greater than X. So let's check it out. So W is 1, and X is actually 1 point. So this is actually false, right? So this thing is false. That's not true because X has more density. So X is going to form a layer below W. X forms the top layer. That's also false. X is going to form the bottommost layer. Y forms the bottom layer. That's also not true. Z forms the layer below X. So according to this, the density of Z is actually greater than the density of Y. So let's check according to the data. So the density of Z, is it greater than Y? Yes, absolutely. That means D is correct. So this statement is true. So that's why I said that floating and sinking concepts are really important, and these types of questions can come in your exam. Moving on, an object weighs 19 Newton on a planet where the acceleration of the free fall is 3.8 meter per second square. What is the mass of that object? Now again, whatever the mass is going to remain constant, and we also know that weight is written as mass times acceleration due to gravity. That means mass can be written as weight divided by acceleration due to gravity. So weight is actually 19 Newton divided by 3.9, and that is going to be equals to around 4.87, and approximately we can just round it off to 5 kgs. Moving on, an object is suspended from a spring balance on the earth. The same object is suspended from the spring balance on the another planet. Which statement explains the difference between the two readings? So on both the planets the mass is going to remain constant. The options are on the next page. I'm going to quickly turn it. The mass is going to be constant. And if you're going to talk about the weight on any planet, it actually depends on the mass times the acceleration due to gravity on that planet. So if on the other planet we are getting a greater reading, that means the acceleration due to gravity on this planet is actually greater than from Earth. That's what we mean, right? Moving on to the options. Both the mass and weight of the objects are greater on the other planet. So this is wrong. Why? Because we cannot say that the mass is greater. This thing is actually wrong. Mass will remain constant. The mass of the object is greater. Again, they are talking about mass to be greater or smaller, so that will be wrong because mass should be constant. The string stretches more easily on the other planet. Now see, this is also wrong. Why? Because the spring, the easiness or the difficulty which with the spring is going to stretch is it depends on the spring constant, and the spring constant doesn't depends upon the acceleration due to gravity. It depends on the material of the spring, right? Last one is the weight of the object is greater on the another planet, on the other planet than on the earth, but the mass is unchanged. So this is absolutely correct. So D option is going to be the correct answer. Moving on, a person steps onto a bathroom scale. The bathroom scale records both mass and weight. Which row shows the readings of the on the bathroom scale? Now these were the questions that I was talking about. So the mass will be in kilograms, the weight will be in Newton. So according to that, the correct answer is going to be option B, right? Moving on, Which equation is correct? Density is equals to mass by volume, or mass can be written as density times volume. So this is absolutely correct, right? Density is actually equals to mass times volume, or mass can be actually written as density times volume. Moving on to the next one. A vehicle sent to explore the surface of Mars has a mass of 200 kilogram. The acceleration of free fall on that is 3.7. Again, similar type of questions, but that's what I was saying, that these are the questions that usually comes in the paper. So weight is going to be mass, that's 200 kgs times 3.7, that's going to be 740 Newton. And with this, let's move to the next one. Question number 10. A student writes about mass in which statement is correct? A ship is floating, has mass but no weight. Mass is scientific word that means the same as weight. Mass is scientific word that means same as weight. So these two are, I mean, they are just same. The mass of an astronaut is same as on the moon as on the earth. So option D is absolutely correct. Why the ship floating has mass but no weight? That's not true. It still has got weight, right? A ship which is floating on, so let me just make a boat instead of a ship. So let's suppose that this is a boat and it is floating on the ship. So still it has got weight, that's mg, but it is being balanced by the buoyant force or the upthrust. Moving on to the next one. A student carries out an experiment to determine the density of an irregularly shaped solid. The solid is placed on a balance and reading is taken. The solid is then immersed in a liquid in a measuring cylinder. Which value should be used in the calculation? So increase in the reading of the after immersion of the solid. So it's and value from balance will be mass. Increase in reading after immersion, and the value from balance should be weight. So value from the balance should be mass. So the option should be from the balance we actually get mass. So either it will be this or this. Now reading after the immersion of the solid, we have to actually find the increase in the reading, because that's what we actually want to find. We have to find the difference in the reading, right? So option A is going to be absolutely correct. A plastic ball has a mass of 4 gram and a volume of 20 centimeter cube. There is a crack in the ball's surface. The ball is placed in a bath of water. Water leaks into the ball without changing the volume of the ball, and eventually the ball sinks. Which mass of water has entered the ball when the top of the ball is first level with the water surface? So what they really mean is, let's suppose that this is the surface of the water, and after getting the crack in the ball, let's suppose after getting a small crack over here, this water starts to fill up, and after water starting to fill up, I'm going to say that now the mass of this ball was first 4 grams. So first it was just 4 grams, so 4 into 10 to the power minus 3 gram, plus let's say m amount of water has entered the sphere times acceleration due to gravity, and this will be actually, this should be exactly equals to the buoyant force at that point when it is at the first level. After that the ball will start to sink, and the buoyant force is actually given as density of the liquid times volume of the solid times acceleration due to gravity, and that is actually equals to density of the liquid. They have already told us that's 1 gram, but we have to write it in SI unit. So that will be 1000 kilograms per meter cube times volume of that is actually 20 centimeter cube, so we'll have to actually change it. So it will be minus 6 meter cube times acceleration due to gravity. I'm just assuming it to be g, right? I'm not substituting the values because they are going to cancel out. So now I'm going to equate it. So I have got I can actually cancel some of the zeros. So I've got 4 zeros over here, it will be minus 2. So I've got 2 into 10 to the power minus 2 times g, and that should be actually equals to 4 into 10 to the power minus 3 plus m times g. So again g can be cancelled out, and then what I've got over here is that m can be written as 2 into 10 to the power, so I can write it as 0.2 into 10 to the power minus 3, and I can write it as minus 4 into 10 to the power minus 3. Let me check if we have got everything correct. Yes, I think I have done it. Oh, just one thing. This is going to be actually, if we have to convert it, this is going to be actually 20 times 10 to the power minus 3. So this will actually become 16 times 10 to the power minus 3 kilograms, which is actually nothing but 16 grams. So this is the correct answer. That is option B. Moving on. A satellite orbits the Earth at constant speed in circular motion. Which statement is correct? The resultant force on the satellite is 0. The resultant force on the satellite is towards the Earth. Although this, I think this question is not related with this topic, but still we are going to cover it. The resultant force is going to be towards the Earth if it is moving with the constant velocity, because centripetal force acts towards the center of the Earth, right? So there's only one question that was not related with the topic, but still we have finished it. Along with this, we have covered this class. Hopefully everything is clear around this simple topic. The motive of this class was just to explain you, just to show you that what type of questions comes from this simple topic of mass, weight and density. If you have any doubt, please write down in the comment section. If you have any request, regarding any other subject of physics, please write down in the comment section. We'll get back to you. I'm going to meet you in another video. Till then, take care. Thanks so much. Bye bye.